Earth observation from the station. Presented by Science at NASA. About 30 years ago, researchers announced that ozone concentrations high in the atmosphere over the South Pole had hit an all-time low. This critical layer of the atmosphere that shields us from the sun's harmful UV rays had a hole in it. And that hole was rapidly expanding. This discovery led to the Montreal Protocol, an international treaty that regulates production of ozone-destroying chemicals like chlorofluorocarbons, or CFCs. As a result, the ozone layer is now on the mend. To study this layer of the atmosphere further, NASA has launched an ozone sensor to help monitor the long-term change in the ozone layer. Called SAGE-3, short for Stratospheric Aerosol and Gas Experiment 3, it will be installed on the International Space Station in 2017. SAGE-3 represents the fourth of a series of instruments that have used similar techniques to measure atmospheric ozone and aerosols, going back to 1979, with more than 25 years of on-orbit heritage. The space station's orbit, different from that of most Earth-observing satellites, makes the station a unique vantage point for collecting valuable data about our planet's health and status. The orbit brings it closer to Earth and allows instruments on board to see our planet at different times of day under varying illumination conditions. NASA is adding to the station's Earth-observing capabilities with instruments like SAGE-3. This instrument will monitor ozone all around the Earth at various times of day and night around the globe, and during all seasons of the year, using light from the sun and moon passing through the atmosphere. Particles, or aerosols, and gases in the atmosphere absorb and scatter light to various degrees depending on their properties, explains SAGE-3 principal investigator Pat McCormick. By measuring the attenuation of light from the sun as it passes through a section of Earth's atmosphere at spacecraft sunrise or sunset, we can determine the quantity and location of these aerosols and gases. Attenuation of sunlight reflected from the moon will be used in similar fashion for additional data collection. SAGE-3 will also measure ozone in multiple levels of the atmosphere, reaching all the way down into the upper troposphere and stratosphere. It will provide a nearly global picture of the tropospheric ozone and features improved vertical resolution over most ozone instruments. McCormick says all of this means that SAGE-3 will provide a very robust and precise characterization of the ozone layer. Another state-of-the-art instrument, the Lightning Imaging Sensor, or LISS, will be installed on station in 2017. LISS will capture real-time total lightning data over much of the globe, even over data-sparse regions such as the oceans, to support weather forecasting and warnings. The LISS instrument for ISS is a duplicate of the LISS that operated as part of NASA's Tropical Rainfall Measuring Mission, or TRMM, which completed operations in 2015. From the station, this new LISS instrument will be able to look much farther toward Earth's poles than it did on TRMM, taking advantage of the station's higher inclination. 3 more instruments are expected to be operating on the station by 2019. The Global Ecosystem Dynamics Investigation, or JEDI, the Ecosystem Spaceborne Thermal Radiometer Experiment on Space Station, or EcoStress, and the Orbiting Carbon Observatory 3, OCO3. JEDI will revolutionize the way tropical forests are monitored, shooting laser beams into tree canopies of the world's forests to take fine-scale measurements of their height and internal structure. EcoStress will study water use and water stress in vegetation. The station's orbit will allow EcoStress to take observations at different times of day across the seasons. OCO3 will collect space-based measurements of atmospheric carbon dioxide to help assess its distribution and variability. The ISS is a busy place, studying effects beyond Earth and also Earth itself. For more news from the International Space Station, visit www.nasa.gov/station. For more science news on and about the Earth, stay tuned to science.nasa.gov.